Today, we're gonna take this rod and we're gonna make this knife. Alrighty guys, so I definitely learned a ton in making this knife, and I want to pass those learnings on to you. I am sure that if you looked closely on that picture that just flashed up on your screen, you may have already been able to see some of the flaws in this knife, and I will make sure to outline those flaws so that you can see my mistakes and not make them yourself. Now, for some of you who don't know, sucker rods are used in a rod pump in the oil and gas industry, and they are a connection between the surface unit and the pump down hole. Living in West Texas, I have an ample supply of used trashed rods, so we want to utilize some of these rods on this knife. So with that background information, I really hope that you guys enjoyed this build. So during the intro, you guys saw me hammer out this 3/4 of an inch thick N97 rod to around 8 inches and 1/4 of an inch thick. Utilizing an old hatchet, I will hot cut the flat portion away from the rod. Now for you subscribers out there, you know that I generally do stock removal knives, but I'm looking to get more into forging just to change things up a bit. So expect some more forging projects down the road. At this point, I am making sure the steel is as flat as possible, and then I will be annealing the steel overnight. To do that, I heat it up in the forge and then let it cool with the forge overnight. What this does is it removes stresses from the steel, and it also allows the steel to be soft so I can drill it and grind it easily. The next day, when I go to retrieve this piece of steel from the forge, it does have a significant amount of scale. Now this scale is very hard and it will tear up my belts. So the goal here is to utilize an angle grinder with a 60 grit flap disc on it to knock off the bulk of the scale. You can also see during this shot that I have a significant amount of hammer marks from my inexperience with the hammer and forging. To remedy this situation, I will be utilizing my DIY surface grinding attachment to make the surface as hammer mark free as possible and also as uniform as possible. In this case, I will be utilizing a slightly worn 60 grit belt, and I was able to get this piece flat and uniform in short order. And this is what that looked like. Alrighty guys, so after doing some online research, it seems as if sucker rod is not hardenable to the point of making a knife. And I talked to some of the guys on Blade Forms. It sounds like you can get this up to about a 50 Rockwell hardness, which is not quite adequate for a knife. However, in order to incorporate this sucker rod into a knife, I'm going to try a sanmai, my first sanmai. To achieve our sanmai, we will be utilizing a piece of 1084 as our core, and then sandwiching it in between two pieces of the flattened rod. Now I ride my blades in my bandsaw until the end, and you can see that here where this one broke. Now these blades are actually pretty good in comparison to the other blades I have bought for this machine. However, if you do ride them to the end, they will eventually break. So make sure to be wearing your appropriate PPE. Now that we have all three of these pieces cut to the appropriate size, we will clean them off and place them in the vise to be welded. Now when I was pulling my welding helmet down from the shelf, I noticed that the front face shield is in dire need of replacement. Luckily, this helmet came with a lot of these shields, and I've just never taken the time to replace them, so I did today. And it made a pretty big difference to be able to see what's going on. I'm utilizing my Hobart welding machine here in a flux core setup. I normally weld with this machine in a MIG setup, but I ran out of gas, so I decided to give flux core a go, and it seemed to work okay. There was a bunch of splatter with the flux core, but it did get all three pieces welded together. Now, I'll mention again that my forging skills are not the best. However, I have forged at least 5 Damascus billets to this point, so I know just enough to be dangerous. On this billet, I did put some borax on the sides to minimize the chance of oxidation getting in between the layers. I also put a little borax on the face of the billet so that I can use it as a temp gauge to see when I'm close to welding temperatures, and it seemed to work fairly well. I start off by setting my welds with very light hammer blows and very brief hammer blows before putting it back into forge. After I feel like I have one solid piece, I start drawing out this billet to its final length. Now, during this process, I realized that I didn't have enough steel for the knife that I was shooting for. So I actually have to do a little bit of shaping here, opposed to just building a rectangular billet. Basically, this means that y'all will be able to see my full inadequacies as a bladesmith. I am going to attempt to get the profile of this knife, or this billet, into a more knife shape. And for the purposes of this project, it actually didn't go too bad. I was able to get a rough knife shape here with a little bit of curvature for a handle and a little bit of curvature for a tip. After I got it close to what I thought was adequate, I went ahead and made sure it was fairly flat, brought it back up to temperature, and left it in the forge overnight to anneal. The next day, just like with our initial flat piece of rod, we had a significant amount of scale on our billet, so I went to the angle grinder to clean this off. However, this time I figured I'd utilize one of my other grinding tools, this cordless DeWalt angle grinder, and I must say every time I use it I realize that cords are not cool and this is way better. The only downside of this machine is that it will burn through these batteries extremely fast, so if you're working on small pieces it's not a big deal, but if you're doing a lot of angle grinding it probably isn't a good solution for you. With the bulk of the scale being knocked off, we can transition to the surface grinding attachment to get the majority of the hammer marks out and then profile the billet. I then trace it out on a piece of paper along with some guidelines. These guidelines will allow me to scale it in my computer. I import the file into NanoCAD and then I will scale it down to match the lines that I draw in NanoCAD. So in this case I drew a 3-inch line and then I lined up the 3-inch mark on my scaled picture. Once I have the picture scaled in NanoCAD, this will allow me to draw along the outside of our trace. I'm utilizing the line and arc feature in NanoCAD to do this. This will give me a representation of our billet in NanoCAD so that I can fit my design within this template. It took a little bit of time, but after I got it done, I was able to see quickly that my original design would not fit on this billet. However, with some slight modifications in the width of this knife, I was able to get everything to fit in a package that I think turned out pretty good. After I have the knife drawn, I will print this out and we will cut it out of the billet in real life. I have utilized this scaling method by taking a picture and importing it into NanoCAD a few times now, and every time I have, it has worked out great. After we have the design printed out, I cut it out with an X-Acto knife and then use a spray-on adhesive to attach it to our billet. We then will rough cut out our shape with the bandsaw and then profile it on the 2x72 belt grinder. And this reminds me, if anyone has any good recommendations for a work rest for a 2x72 belt grinder, please go ahead and mention that in the comment section below. I am in the market, so to speak, for at least a design of one. I may end up building it myself, but if there is a really good cost-efficient option, I may buy one. The work rest on my machine is probably the part of my grinder that I dislike the most. What you see me doing here is marking off where my jimping will start and then putting a file guide on the knife to guide my checkering file to create this jimping. Now, I got this file after watching one of Jeremy's videos from Simple Little Life, and I've been very happy with it so far. The only thing that I don't like about this file is that it seems to leave one shallow line towards the handle of my jimping, and you can kind of see it here in this mill shot. Now, so far it hasn't been an issue because I end up taking away a little bit of material from my spine when finishing the handle, and it ends up being flush at the end. But I wish it wasn't there at all, because sometimes I have to grind the spine a little bit longer than I would like to get rid of that one shallow jimping groove. On the handle holes, I'll be drilling 2 number 12 holes for our fasteners and then some 1/4-inch holes to lighten up the handle of the knife. Now, normally I utilize Corby fasteners and drill a number 13 hole, and I have a lot of experience with Corby fasteners, and I feel like I have them figured out fairly well. But in this case, I wanted to try out a new fastener. I'm not exactly sure what the name of them are, but you will see them later on, and it actually comes back to bite me, on this knife at least, trying out something new. I realized that I had the opportunity to test out what this is going to look like with this cutoff piece from the end of our billet. So I heat treated it and then file tested it to make sure that it would harden, and it did. Cleaned up the finish and then etched it. And the goal here was to be able to see the transition between the sucker rod and the 1084. After 15 minutes in the etch, I was able to easily see the transition between the two steels. So this was a promising moment. I knew that I would be able to see a pretty cool line when I etch my finished sandmine knife. I also went ahead and broke this piece to see what the grain structure looks like. And it did look fairly tight, as I would expect for 1080. So now that we have the blade profiled, drilled, we have the sharpening notch milled in, and we have our jimping on the spine, we can go ahead and heat treat this blade. I did 2 normalizing cycles, which is bringing the blade up to somewhere in the neighborhood of 1600 degrees Fahrenheit, and then letting it cool to room temperature twice. This will remove stresses from your blade. I do this by putting a wire through one of the holes and hanging it off my power rack until the blade cools. I figured I'd utilize this quench plate angle iron vise method that I picked up from Alex Outdoors to minimize the chance of warping in my blade. I quenched the blade in Parks 50 and then traversed my shop to get it clamped up in the jig. I kept the blade in the oil for about 5 seconds before moving over to the jig. Now my jigs were not perfectly square with each other, and I think that was part of my problem because I did pick up a very, very slight warp in the tip of my blade. So I clamped the blade up just flat in this case and put it in for my first tempering cycle for 2 hours. I try not to work out any of the warps in the first tempering cycle since the blade is very brittle at this stage. In the next tempering cycle, I put 2 washers down to keep the blade relatively straight along its flat, and then I bend the tip towards the left there so that I can bend against my warp. And after my second tempering cycle, my blade came out straight. I then put the blade on to the surface grinding attachment for the 3rd time in this case, and got the surfaces to a 400 grit cork belt. I started off with a 120 grit belt, moved on to a 280 grit gator belt, and then lastly finished with a 400 grit cork belt. Now that the flats of our knife are brought up to an acceptable finish, I will put some marking fluid on the edge and scribe our center line. This center line will be the target. I start off with a worn 60 grit ceramic belt to knock off the edge at a pretty aggressive angle. After that, I move on to a fresher, newer belt so that I can start working the bevel towards the spine. If you start off with a new belt right off the bat, you end up tearing up a lot of the abrasives on that nice fresh belt. So this is what a 60 grit ceramic belt finish will look like on your knife. I'm utilizing the 60 grit ceramic shredder belt from Combat Abrasives in this case. After I get the 60 grit finish, I'll move up to a 120 grit J-Flex finish. It is at this point that I will hang the belt off of the side of the platen slightly and get a nice radius to plunge. Since I'm trying out some new things in this knife, I stopped at 120 grit finish because I wanted to see what that finish would look like etched. I did also notice that I have a slight surface imperfection towards the tip of this knife, as you just saw. I don't think this goes very deep, but it is there and I didn't like it. After getting my maker's mark etched on the blade, I put it into the acid. After about 5 minutes, I take it out and clean it off with some steel wool, and then put it back in the acid 2 more times. This is the finish I was able to achieve with about 15 minutes of etching time in a 50-50 solution of ferric chloride and water. I'm going to be utilizing some wood on this knife from Pop's Knife Supply. I'm not sure which of those 2 it was, but it ended up looking pretty good, so I'm going to have to figure out what kind of wood this is. It's one of those 2 that I just popped up on the screen. I will say that it was a bear to grind, and if I didn't have a nice fresh belt, it would have taken forever. So I mark off the angle on the front of my scales and grind them in with a semi-fresh 120 grit J-Flex belt. I then sand the finish on the front of the scales up to 1000 grit with Rhino Wet sandpaper. After I have the front of the knives sanded up, I put the stop on my mill to drill into the scales with a counterbore 3/16 of an inch deep. And this is how that turned out. I will once again mention that I love that counterbore from Pop's Knife Supply. So I do my normal Corby math here, which is the total width of all three pieces minus 3/16 times 2 to get the inside width that I'll need to modify the Corby's to. However, in this case, I'm using this new fastener here. So I attacked it the same way I would normally attack a Corby fastener. I need to bring this 0.42 down to about 1/4 of an inch. What I didn't know, and what you will see later, is that the void on these fasteners are much larger on the female ends of those heads. So you'll see what I'm talking about a little later. So I get everything nice and cleaned up, lay down some tape on my scale, and measure out 2 equal parts of G-Flex epoxy. I then put epoxy into the holes where the fastener heads will sit. Now these fasteners were also a little tighter than the Corby fasteners normally are in the counterbore that I drilled, so it took a little finagling to get them in there that I wasn't expecting, and I didn't check like I should have. But that's fine, they did end up fitting. I got the whole thing together and I cleaned off the front of the scales where I had a little bit of squeeze out. Now I will mention that I should have gone back about 10 or 15 minutes later and make sure that no more had squeezed out, because in this case a little bit more did squeeze out from the front of my scales, and I normally really don't like it when that happens, so I should have cleaned that off, but I didn't. This is when I noticed the folly of my ways, and there is a large visible void when I cut off the heads of each one of these fasteners. So to illustrate exactly what happened here, so it won't happen to you, I'll make a detailed drawing of what happened. This pink thing is our blade, and then these purple sides are our scales. We counterbored into the scale 3/16 of an inch, and then the head of the bolt sits out further than that. Now this void of the female section also sits out further than 3/16 of an inch, so when we cut the head off, we have this big nasty void to contend with. As you can imagine, I was very disappointed with this outcome. Back in my early days when I was learning how to utilize Corby fasteners, this had happened to me once or twice, and I quickly realized that I need to do more math when putting Corbys onto a knife and measure the void of the Corby fasteners. So with that in mind, whenever you are utilizing new fasteners like these, make sure you measure the depth of the void. I'm sure these fasteners will work just great on thicker handle scales, but for 1/4 inch scales, I think the voids are probably too large. I decided to continue on with this knife and finish it out, because the handle fasteners having voids in the front of them is more of a cosmetic issue than a function issue. This knife will still be completely functional, just slightly ugly when it comes to the fasteners. It is for that reason that this knife is now my knife. So as you've been able to see, we are getting this handle shaped out on the belt grinder. This is as far as I took it with the belts, and then we will finish it out with hand sanding. I normally start off with a 320 grit sandpaper, work up to a 600 grit after that, and finally a 1000 grit paper. This process actually doesn't take that long, considering that I'm coming off of the belt sander at a 220 grit finish. I make sure to clean the debris from the inside of these fasteners, and then hit the spine with the Scotch-Brite belt to make sure all of the satin scratches are going in the same direction. Then pull out the Win water-cooled sharpening system and put my edge onto this knife with a 220 grit wheel. Then strop the edge and I have a razor sharp little knife. Thank you guys for watching this video. I hope you all really enjoyed this build, and if you did, go ahead and hit that like and subscribe button down below. And with that, I'll catch y'all on the flip side.